Hello everyone, welcome back to our Android system and embedded engineering podcast. In this chapter, we will dive deeper into the core concept of OSP and embedded Linux, breaking down complex idea into easy real-world example. And whether you are just starting out or aiming to become an expert, we will guide you step by step, explaining not just what things are, but why the work is that way. Yeah, let's get started now. Okay. So this chapter is all about getting our or your development environment ready so you can actually build, test, and experiment with Android open source project. And this is chapter we will explore installing Android SDK, the setting up an Android virtual device, creating a VD, and we will test it not goldfish, we will using the cuttlefish and the OSP build environment. Okay, and we will moving to create the own repository mirrors and so on, repo and manifest, and we will explore a lot of things here, the tools and so on. So the main goal here is are the installs Android SDK and the setup an Android virtual device AVD, and so you can create one from scratch. So you can also emulate Android hardware in your machine by the AVD. So, and we will also discover and set up the OSP build environment, which means getting all the tools and the dependencies you need to build Android from source, and then actually building a test image, and also learn how to create your own source code repository mirror, which is super useful for working in teams or when you want to faster and more reliable access to the OSP code base. And also the chapter start with a quick summary, as you see now here. This is already summary of Android version, since the book uses Android emulator as a virtual hardware platform. It picks a specific Android version to keep things consistent. And here you, as you see now here, Android 7. Okay. Yeah, Android 7, this is the language so is used throughout, but it also mentions that the author started with Android 6, and the code for that is available on, on GitHub. Okay. So the key point is that both development environment and the OSP source code have changed a lot between Android 6 and 7, so it is important to know which version you are working with. Before diving into the setup, the chapter will give a brief overview of the difference and the different Android version, just to set the context and so on. Okay, so we can hide this, move to the next page. As you see now, here, as you see now on this page, yeah, to set up the OSP build environment, you need to pay close attention to two main things. First thing is the host operating system, usually Ubuntu Linux, and the Java SDK version. This is the two things you need to take care about. So even though Ubuntu is the recommended host, you can use other Linux distribution, but Ubuntu is the easiest and the most supported. And for Android versions, yeah, I think 2.3.x is gingerbread. So, and above, you need a 64-bit build environment. Older version use 32-bit, and yeah, and also each Android release has a recommended Ubuntu version. So, for example, the older release uses Ubuntu 10.04, while newer ones are up to 14.04. And now I use more than that, so you can use to 22.04 or 24.04 and so on. It is best to match the recommended version, but you can often use a newer one. And the Java SDK is also version dependent, so up to Lilipop, Oracle GDK was used from Lilipop, and above OpenGDK is used and so on. So, and yeah, as you see now, the table on the page summarize which Android version, nickname, SDK, API level, host architecture, GDK version, and Ubuntu version. Yeah, okay, are needed for each release. So Goldfish and Rancho for refer to Android emulator hardware platform supported by each version. Okay, this is just brief about this page about the tables and so on. So this table also you need to this table already is your quick reference for matching Android version with the right build environment. So each row shows Android version like Honeycomb, Ice Cream, Sandwich, Jelly Bean, and etc. So its version number, API level, required host architecture, either x86 or x64, which Java JDK to use, Oracle JDK 6 or JDK 8 or 17 and so on, and the recommended Ubuntu version and so on. So the X mark show which emulator kernel is supported. Goldfish is older QEMU based emulator, or Rancho is a newer QEMU so based emulator. So for example, if you are building for NAGWAT 7.1 by 25, you need 64-bit host, OpenJDK 8, and Ubuntu 14, for example, 0.04. So Rancho is supported but not Goldfish. You need to take care about this. Yeah, maybe this is a trade-off, but okay. And yeah, the notes at the bottom explain, you can see it. Okay, so this note already, Goldfish is the old emulator QEMU1 and Rancho is new one QEMU2 from KitKat Earnwardis. For NAGWAT 0R2 API level 24. Okay, and the 25, the box could support up to API 25. If you install KitKat or newer, you will find two kernel files, the kernel QEMU Goldfish and the kernel Rancho. Okay, this is Rancho. Okay, this is already just as a theory. Now, my question here, how do you install the Android SDK and set up an Android virtual device if it is especially using an older SDK version? I think maybe it's practice. We can do it as a live session interactive. Maybe by myself alone, maybe by yeah, and the already the interactive session and so on. But we can already now read the book and trying to analyze page by page. So the page explain how to install the Android SDK and set up an AVD, which is essential for testing and the development without real hardware. And even you have a full OSP built environment, having the SDK makes it easier to create virtual device and run emulators. And the recommended host OS here is Ubuntu for 14.0.04 and above. You can use the 22, 24 as you see in the future. So you should download the Android SDK for the Linux, then extract it your home directory, and the tool in the Android SDK changed after API level 25. So the book gives the instruction for both old and the new SDK. And for older SDK like Android SDK, are 24.4.1. After extracting, you will see directories like add-ons, so build tools, platform tools, and you can see SDK, readme text, and system image, temp, and tools. You should add the platform tools and tools directory to your path environment variable so you can run SDK commands for anywhere from anywhere. So you this book, yeah, uses a virtual device based on API level 24.5 for testing. Yeah, I think this is already clear steps for everyone. I think a lot of people know these steps, and in the practice we will do it step by step. Yeah, this one, yeah, this is just screen. Here, how do you launch and use Android virtual device manager to create a virtual device? So as you see now, the screen shot shows the classic AVD manager window, so which is used to create and manage Android virtual device for testing. The launch, yeah, you launch the AVD manager by running command Android AVD in your terminal, and the window lists all your existing virtual devices, AVDs. If you have not created it in yet, so the list will be empty. So just like in the screenshot as you saw. Okay, From here you can click create, okay, and to start making a new virtual device and use start to launch a selected DVD. And you can already also press on edit, repair, delete, and the details let yeah, you manage existing EVD. So the warning also here at the bottom tells you if any EVD are broken or need repairs, and so on. So the Android or the EVD the EVDs are stored in your home directory under .android EVD. Okay, this is just to create a virtual device, launches Android Virtual Device Manager by running the Android EVD. Here's my question here. How do you configure a new Android virtual device EVD for API level 25 in the EVD manager? So as you see now the screenshot and the screen so shows the setup for creating a new EVD named 25 by 86 using EVD manager, and the configuration you should use for a typical Android 7.1.1 API level 25. This is AVD, as you see in AVD name, device, and device here Nexus, and target Android, CPU API, Google APIs, Intel, and keyboard here, hardware, keyboard, present checked, and so on. And scan front camera, back camera, RAM, VM, heap, and the internal storage is the card, emulator option, and so on. This setup gives you a good balance between performance and compatibility for testing OSP builds. And using the Intel Atom CPU API makes the emulator much faster on most modern PCs. Okay, use host GPUs as checked to improve graphics performance, and this display size 480 by 800 HDPI is a common baseline. Okay, this is as display. Okay, the common baseline for compatibility and so on. So this is just yeah, this is to configure a new VD for API level 25, and as you see now, okay. Yeah, we will already explore the new version from Cuttlefish and how can we do this is in yeah a lot latest updates. Okay. Here, my question here, how do you create an EVD using the latest Android SDK command line tools, and how do you test it with the goldfish emulator or cuttlefish? Okay, in the latest Android SDKs, the old Android EVD command is deprecated, and you now use SDK manager. Okay, and the EVD manager for managing SDK components and the EVD, and all of the OSP has already check it before or see it before. So first use SDK manager dash dash update to update and download the necessary SDK components. And if you try Android EVD, you will get an error saying the command is deprecated and unsupported. So instead you create a new EVD with EVD manager. For example, EVD manager create EVD dash N A25 by 86 dash K system image. You can already run already put semicolon Android dash 25 Google APIs semicolon x86. So this is you can already mention dash dash tag. So Google APIs, this is create an AVD named A25 by 86 using Android 25 Nagwad x86 system image with Google APIs. You will prompt it about creating a custom hardware profile. Usually you can answer no for standard setups. So to test the EVD with goldfish emulator, this is a classic QEMU based emulator, so use emulator at A25 by 86 dash verbose dash show dash kernel dash shell dash engine classic and so on. This command starts the emulator in verbose mode, show kernel logs, open the shell, and focus a classic engine. Okay, this is just with latest Android SDK. You cannot use Android AVD anymore. So instead, update your SDK with SDK manager dash dash update. Okay. Yeah, this is just summary for this one. Here you can see how do you monitor and debug Android emulator instance and what is the difference between goldfish and ranchu emulators. So as you see, This will show how to monitor and debug Android emulator instance using command line options. So like dash verbose show, this is show detailed emulator debug info, and dash show dash kernel, as we mentioned before, out with kernel debug message, and dash shell. This is open a shell using stdi, okay, as a command line prompt. And dash engine lets you pick the emulator engine, auto classic goldfish, so, or QEMU2. This is ranchu. Yeah, and also classic use the goldfish emulator, older QEMU, and QEMU2 use the ranchu emulator, newer QEMU2. So if you don't specify anything, so the system tries ranchu first, then falls back to goldfish if it fails, and so on. So the log example shows the emulator using a kernel image at system-image Android 25 default x86 kernel QEMU, which means it is running goldfish, okay. And also both ranch and the goldfish are based on QEMU but use different kernel and QEMU versions. You can check with QEMU version is used by running emulator dash engine classic dash QEMU dash version, and so on. So for goldfish you will use something like QEMU PC emulator version 0.10.50 Android, and there is no bug in newer emulator version when using the classic engine, which can cause error like emulator error. Android QEMU get serial line cannot create yeah, something related to serial port. So this is just warning. If you see it, it is likely due to emulators handling of serial port in classic mode. Yeah, just for information, okay. And here, how do you verify the Android version? Okay, kernel version and build details on an emulator after booting a custom OSP image. Okay, as you see now on the screen, so the phone shows the phone status screen from an Android emulator running Android 7.1. This is not good for x86. So after you put your emulator with a custom or reference OSP build, you can check system details by going to setting about phone, and what you can verify Android version confirms the OS version. So when 7.1 based on your already version OSP version. So in this case this is 7.1, and Android security patch level shows the security update date. So and also baseband version usually unknown on x86 emulator, so since there is no modem. So and another kernel version shows the kernel Linux kernel version, build user, and build time. This is crucial for confirming your kernel change or custom kernel builds. So and also we need to check build number. This is build number identifies the exact build, useful for debugging and confirming you are running the intended image. So you can also check the emulator and QEMU version using emulator dash version. This is for emulator version, and emulator dash QEMU dash version. This is for QEMU version also, one for emulator, one for QEMU. And this process is essential after flashing or building a new OSP image to make sure your changes are present and the correct kernel is running. So this is just for whenever you are debugging kernel or system level changes, always check the screen first. It is fastest way to confirm your build actually mode. Okay. uh, this is actually made it so onto the device emulator. So and you need to catch mismatch between what you build and what is running. So this is just for hint. Okay, this is a real world tip. Sorry. Here we can see what is the difference between Goldfish and Rancho Android emulator, and how do you test Rancho emulator with a custom kernel. So yeah, as you see now, also this is, you know, you can check now mm, about something related about phone and so on. But now let's move to my questions. Yeah, difference between Goldfish and Rancho Android emulator, and how do you test the Rancho emulator with a custom kernel. I think the book here shows a section from a book explaining how Android emulator use different kernel and file systems depending on the engine. Okay, Goldfish here it is classic engine and Rancho QEMU engine. Okay, are two different QEMU based emulator. And yeah, you can say goldfish uses an older kernel. Okay, example, yeah, there's 3.4.67 and a specific file system image, and rancho uses a newer kernel and may use a different file system image even for the same avd. Okay, the OSP build system doesn't include the kernel by default, so you must build and provide the kernel image separately. Okay, and when testing, always check both the kernel version and the build number on the device setting about phone, as we mentioned before, to confirm which kernel and the system image are running. To test the Rancho emulator, you use the emulator command with dash engine QEMU2, or just omit the engine since Rancho is default in new SDKs. So you can also check something like the log will shows the kernel path. Okay, this is already, yeah, to confirm the emulator backend and so on. So when debugging OSP or custom kernel, always double check which emulator engine you are using, as Goldfish and Rancho can behave differently and use different kernel images. This is especially important if you are testing kernel changes or debugging low-level issues. As this is just that's it on here, nothing else here. Yeah, here as you see now, how to quickly check kernel and the QEMU version in Rancho emulator and why it is matter. So you can run emulator dash QEMU dash version to get QEMU version. Once uses newer QEMU, and inside emulator go to setting about phones kernel version to see running kernel, and they check build number for OSP build, as you see, as we mentioned before also. And knowing this ensure you are testing the right kernel and emulator backend, avoiding wasted debugging time. And Rancho is modern, Goldfish is older, and different version affect behavior and features. Okay. Here, yeah, what are the key difference between Ranch and the Goldfish emulator, and what's needed to set up the OSP build environment for emulator development? So Rancho uses kernel version 3.10.0, which is newer than Goldfish kernel, and the file system used is the same for both, but Rancho support more modern Android features and hardware emulation. OSP build environment for emulator build ABI 25 in this example use Ubuntu, yeah, 14.04, 64-bit and OpenGDK 8, and the recommended hardware at least 8 GB RAM and 500 GB disk. Yeah, now you can already using OSP 16 with 16 gigabyte RAM at least, with 500 GB free on disk. Okay, 250 for download, and the same for the same for the build. Okay, so required package install essential build tools and library with Android was provided. Sorry, apt get dash get command. So get gcc make zlib and so on. This is as etc. So why this matter? I think using the light emulator and build environment ensure compatibility and smooth development debugging for OSP and the hell work. And the mismatch kernel, okay, or missing package can cause build failures or emulator bugs. Take care about the commands and the library you will install, and check every command before you run it. So that's it here. Yeah, as you see now, this is a command, and for install build essential for the app call and so on. Here, yeah, just what are steps to install OpenGDK 7 and 8 for Android build environment on Ubuntu 14.04, and why is this important? I think you can check it through YouTube or already from the already documentation from Google, so you can check it. For building all the Android version like 6, 7, you need both on OpenJDK 7 and 8. And OpenJDK, yeah, it is install directly with sudo apt get update and sudo apt dash get install OpenJDK dash 7 dash GDK. And for OpenJDK 8, I think downloaded it from .deb package for 64-bit from archive.ubuntu.com. And optionally, you can already verify each files show 256 checksum. This is already hashing, okay, with show also 265 sums. Is you can downloaded the deb file. And the install was sudo apt get update and sudo dbkg -i downloaded .deb file, okay. And also if there are missing dependencies, fix with sudo apt get -f install, okay. Why this is matter? Android build tools are picky about Java version. Okay, wrong JDK can cause build failures or weird errors. So verifying a checksum, ensuring you are using safe, uncorrupted files, and this setup is a must for stable, repeatable OSP builds, and especially for legacy Android version. Okay. Yeah, let's take. Yeah, now what are steps to set up repo and initialize OSP source tree for Android 7? And yeah, set up repo tool. So create a bin directory in your home folder, add it to your bus, and download the repo scripting using curl, and make the script executable. And you can check already the Google documentation, everything already listed, yeah, with clear step by step and so on. So you can also starting with initialize OSP, use the repo init with correct manifest URL and branch. For examples, Android-7.1.1 underscore R4. Okay, so run repo sync to download all source code, and you can take about these commands from screenshot as you see. So make dir so tilde with slash bin, and this create bin directory in home and pass equal, so with bin and pass. This is add bin to pass, and you can starting with download repo tool with curl, and then you can make repo executable with this command change mode. So this is the first thing, and you can starting with initialize repo as you see here, repo init, okay, dash u https and so on until the end. So this is initialize repo for Android 7.1.1 underscore R4, okay. And then you need to download all OSP source code by run this command repo sync, okay. Yeah, this is so yeah, this is a standard way to fetch and manage OSP source using repo, ensuring you get all right get projects and versions. Always double check the branch -p to match your target Android version, and this setup is foundation for any OSP build or customization work. And you can already test it together through the interactive session or in a live and so on. Okay, let's move to next one. Yeah. Okay, so let's continue the steps to starting build OSP and Android emulator images, and how do you select the right target for the emulator. Okay, so after syncing or sensing the OSP source, you will see top level folder like build, like device, framework, etc. This means your source tree is ready. Okay, to build emulator image, use x86 targets for speed, unless you specify need ARM and so on. So run the environment setup scripts. Yeah, this is already dot or source build slash env setup dot sh. This setup your build environment and load the helper function. And yeah, let me, okay, so this is already the command to build to already to prepare your environment. This is to yeah, this is, as I told you, this is set up your build environment and root helper function, and then you can run the launch command. Okay, this one, Launch command here it is to, yeah, I think this command to pick your build target. You will see a menu with options like as you see now, OSP arm energy, OSP arm 64, and so on. You can see also the cuttlefish and a lot of build targets. Okay, and for emulator work pick an x86 or x86 64 targets. So this is like option 5 and the option 6, anyone, and you can move, yeah, option 5 for example, or x86 ng. So for best performance, after selecting you can build with make or m. Okay, I think x86 emulator run much faster on typical machine due to virtualization, and the picking the right launch target ensures you are building image compatible with emulator you want to use. And this is a standard workflow for OSP emulator development. Every Android system engineer should know it by heart. Okay. As we mentioned before, so now how do you set up the build environment as we mentioned, and starting a build on Android XT x86 emulator image? So start by running the env setup.sh as we mentioned, script to set up all necessary environment variables for the build, and use the launch command to select your build target. Let's choose OSP x86 ENG, so for Android x86 emulator. This is sets variables like platform version, target products, as you see now in this list. Yeah, after you run all the commands, you will see this already configuration or set or the variable set. So like we mentioned, target build variants and architecture details. To build this, yeah, to build, use this command make dash g4. Okay, yeah, where dash g4 means using the 4 parallel jobs. Okay, adjust based on your CPU cores, for example. Okay, so the output shows all the key environment variables and confirms you are building x86. And yeah, running env setup and launch, ensuring your build is configured for the right device emulator, and building with the correct target, avoid mismatch and emulator boot failures, and using barrel jobs like dash g4, dash g8, dash g16, and so on. This is speed up the build process, and which is important for productivity. Okay, here what happens during the Android system image build process, and how does barrel build dash g4 affect build time. So as you see, the build environment setup and the process of creating the Android system image system.image for x86 and 64. Key environment variables like host arc, host OS, and the host OS extra are set for 64-bit Pinto 14.4 build. So the build uses make x84fs, this file system, to generate the system.image. Okay, this is file, okay, specifying parameters like block size, inode size, journal blocks, and so on. The output details the file system structure, block size, inode, journal blocks, and total blocks. And the build process is parallelized, okay, using make dash g4, which means for jobs run at once, leveraging multi-core CPUs. On a high end Intel Core i7, for example, the build can still take about 40 minutes, but using the G4 or higher, depending on your CPU, significantly speeds up the process. And you can adjust the dash G value to match your CPU's core count for optimal performance. Okay, so understanding the build output helps you debug issue with the image creation or file system parameters and so on. Using parallel build, this is a must for productivity, as we mentioned. Single thread builds are much slower, and knowing how to interpret the build log, block size, inode, etc., is useful for troubleshooting storage or put issues on emulator or real devices. Okay. Yeah, okay. How do you test your freshly built OSP image using Android emulator, and what files are required? After building OSP, your output images are in the OSP out target product device name. Okay. This is just the directory after building OSP. So the key image for running the emulator are system.image. This is Android system partition. This is mandatory. You need to get it. So another one, user data.image. This is writable data partition. You need it. And another thing related to initial RAM disk. This is RAM disk.image. This is already three image. We need these files. Okay. There is no kernel image by default, so in this output, so for now, so you use a pre-built kernel from Android SDK. To launch the emulator with your image, you can use a script like as you know, I think you can already using emulator. Yeah, this is already we get it in the page before, like emulator A20 at A25 by 86. Okay, dash purpose dash show kernel and dash system. You can mention dash system here with the path of yeah $sign out folder. Inside it you can check the system image dot system dot image, and also RAM disk. Mention the flag RAM disk with out, also RAM disk dot image, and any data with out user data. Okay, this command tells the emulator to put already using your custom built images, showing kernel logs for debugging. The output folder structure and the image names are standard for OSP builds. Knowing that this help you quickly locate and test your build. I think this is testing your image in emulator is fastest way to validate a build before flashing real hardware, and understanding which images are needed and why is key for debugging boot issues or customizing the system. And you can using the dash show dash kernel flag is super helpful for catching early boot kernel panics. Okay, this is what we need to know from this picture. We talking before about how do you verify your OSP build version and the kernel after launching the emulator, and what are common issue with older Android emulator device. Okay, after starting your emulator with a custom OSP build, you can check the Android version, kernel version, and the build number by navigating the setting and the Android phone and the status in the emulator. So as you see, the screenshot already shows an emulator running an Android version 7.1.1 kernel version. As you see here, this is kernel versions 3.10 and point 0 and so on. Okay, this is Android version, this is Android security patch level, this is Android kernel version, and this build number. Okay, and I think maybe for Android 6.0 and earlier there are known issue with ranchu emulator device. You may need to use classic image or update the manifest to include latest emulator, or use the cuttlefish in latest update from 13, 14, 15. This is as a version. So I think this is verifying the version as we mentioned, and the kernel in the emulator is a quick sanity check that your build process work and the right images are running. So knowing about the Rancho Classic device issue help you to troubleshoot emulator boot failures on older OSP version. This step is standard in both development and interview scenarios. Always confirm your environment before debugging. Okay. Yeah, we can already take this as the last page, and then we can continue on the next pulse, inshallah. So here we can say what are the difference between SDK and the OSP emulator image, and why would you create your own OSP repository mirror. Okay, so as you see now is in the table. So yeah, as you see, it is already compared between SDK goldfish rancho and OSP emulator images Android versions. And as you see now, both SDK and OSP images here use 7.1.1, and the kernel version SDK uses 3.4.67 goldfish or 3.10.0 rancho, while OSP uses 3.10.0. And the build number SDK and OSP build have different identifiers. OSP includes the build target and timestamp. So the kernel version and the build target affect an emulator compatibility and the feature support. OSP images are built from source, so you can customize and debug at every layer. SDK images are more stock. Okay, So for deep system work, HAL kernel framework OSP is the way to go. And we can already take the creating your own repository mirror. So you can downloading the OSP from Google is slow and bandwidth heavy. So a local mirror lets you quickly switch version, test configs, and avoid repeat downloads. So this is a huge productivity boost for teams or anyone doing frequent OSP work. And you can update your local manifest and repo config so to point you to your mirrors, making things think much faster. I think in automotive and embedded projects, team almost always uses a local OSP mirror to save time and control dependencies. It is one-time setup that pay off every time you need to think or branch. I think I will stop here with creating your repository mirrors, and we will continue again in the next OSP. And thank you until I see you again in the next pulse. Thank you. Bye bye.